So now that I'm introduced, I can skip the first slide. Typically, I forget where you can follow up on presentations that I do, so I put the last slide first this time. The reason for that is everything I show you here is on software that's available on the internet. So you can get the technology preview for JDeveloper 11 that I'm going to use in this session from OTN. Plus, you will find a lot of tutorials, documentation there that you can also download and try. Plus, there are 2 forums where you see my name all over the place. I'm quite active in answering questions on those forums. We have one forum for JDeveloper general questions that will be production versions 10.13, and there's one specific forum for 11, which is perfectly suited for asking questions about the 11 release. Now, just in case I leave some question unanswered during my presentation, just post them then, I will catch it, or if I can't provide you the answer, I just forward it to whoever is the expert in that area. So, the structure of my presentation, well, of course, I decided to start with a small introduction, but then talk about some key features in Java EE 5. I can't cover the whole Java EE 5 stack, but just picked some interesting topics that I thought might be of interest of you. Like talking about annotations. So annotations have been part of the Java language since Java 5. Java EE 5 now starts picking them up, and you will see the benefits you gain out of that. Enterprise Java Beans 3.0 and GPA, I'm touching on improvements made in this area, changes in the architecture for those not familiar with it, or those that used to work with Enterprise Java Beans 2.1 and 2.0. This afternoon there's a presentation by Deepu Panda and Mike Heath. They run a very in-depth Agb session on Agb in Action, I think they call it. You might want to visit that to learn about how to build an application with it. We will talk about dependency injection and what that all means. Now, what is a dependency injection? Sounds like you go to the doctor and you get an injection. Well, in fact, it's almost behaving like that. We talk a bit about Java server faces as a UI building framework within Java EE, and then I want to briefly cover web service development within Java 11. Java 5, sorry. One of the reasons why we decided also to have this track within this conference is that because Oracle always somehow has the reputation that the tools that we build only work with Oracle frameworks, which in that case would be Oracle Business Components. Now we try to revert that a bit and show you that we can do pure Java EE development if you're a fan of that one. So the benefits of the Java EE standard. You might wonder, so why are people at all looking at Java standards if there's so many open source projects out there and so many cool languages as we just got introduced to Groovy? Well, one reason is, after all, Java EE seems to be the foundation for it. Yeah, so a framework always runs on top of something. And if this something doesn't exist, then the framework will have a much harder time to exist. Second argument is that there are a lot of people that like to go with no strings attached, as I call it. So that means that they want to have an application being built that they don't need to think about where to deploy it. So they need to be kind of flexible in deploying it to different J2E containers, no matter what the vendor is. So only because you build with JDeveloper shouldn't mean that you have to deploy to Oracle, right? So you can deploy to JBoss, BA, well, now BA is Oracle, so forget about that. But you can use, as said, JBoss or any kind of J2E container that is certified for the Java EE platform. Now, one of the disadvantages that many developers see within the standard is the behavior of change, or the speed of change. Now, Java EE as a platform, as I see it, is like an oil tanker. Now, if you want to change something in that, the turnaround takes a long, long time because it's a community process. It takes a long time for all to agree on a new change. Whereas open source is kind of a speedboat, yeah? So if there's a change needed, then there will be a new open source project, and right away you can adapt the technology. And one of the examples where the oil tanker slowly shifted, for sure, is Enterprise Java Beans, because that first had been in open source and in a vendor implementation. But still, I think that Java EE as an operation system, if you see it in quotes, as an operation system really makes sense to look at and really is worth the effort that the community puts into that. Plus, I see a big advantage in having open source, because open source just uses that platform to build more frameworks that respond to the immediate need of developers, and then kind of acting as a blueprint for the standard to follow up. So what's in the box if you use Java EE 5? First of all, you get Java Server Pages 2.1, and you get Java Server Faces 1.2. Now, while this doesn't seem to be very impressive at this time that you see that, one of the remarkable changes in here is the use of expression language. Now, expression language is a dot notation, it's kind of a scripting notation for you to access an object that exists in some kind of scope. It's a request, application, session, you name it. But the notation was different in JSP and in Java Server Faces. And the reason for that was that the Java Server Faces 1.1 implementation of expression language was a specific implementation for Java Server Faces. So while Java Server Faces still has an implementation that looks different, you can use the JSP 2.1 expression language notation now within Java Server Faces. So you have a kind of consolidation, especially when you code with it. Servlet 2.5, Agb 3.0, which is what I'm talking about a bit, Web Services 2.0. The least change, unfortunately, if you ask me, because I'm kind of a security fan or geek or lover, is JAS. For some reason, JAS doesn't move. So since the invention of JAS in Java EE 1.3, this hasn't moved. So there was no change in that. Now, as a consequence, and this is again what I said, if you see the J2E stack as a platform, yeah, as a consequence, vendors and open source organizations build their J2E implementation on JAS. So you see, for instance, a lot of J2E containers today that perform their normal container managed authentication, which is the native onboard security that you have within J2E, they implement that with JAS. Now allowing you, if you're an expert in JAS, to write your own custom login modules, extending the security provider that you can use for authentication and also authorization. So there come kind of a number of JSR that plays into the line of JAS, but nevertheless, JAS itself hasn't changed. So it's still on version 0.1, which might you think that's the first release of JAS that we see in Java EE5. It's not. It's basically, it has a history and it's a very proven security concept. So let's start with annotations. So annotations started in Java 5, just as a directive, as a kind of a hint for the compiler to handle specific methods. You could flag, for instance, a method as an override. Not all annotations really are compiler directives. Some are runtime directives. Some are just to suppress exceptions to be thrown, and so on. Now, this now got added with a common set of annotations for Agb, GPA, for servlets, and for web services. Now, the goal here is, especially in the Java EE land, is to reduce the number of artifacts that you have to maintain with your code. Now, especially within Enterprise Java Beans, as we will see, there's a lot of classes that you had to generate in Enterprise Java Bean 2.1 and 2.0 that are now missing. You don't have to maintain interfaces. Instead, you just use POJO interfaces. You don't have a specific Agb remote interface to maintain, only to get Hello World working. For web services, it's even simpler. You can now forget about a lot of classes that get generated when you do web service proxy generation. It's just an annotation that points to the endpoint and that then makes it work at runtime. So this is just a list of some of the annotations I picked up. You see there's a resource annotation. Well, what would you need the resource for? I have a slide that shows you how in Java EE 1.4 you would do a resource lookup using GNDI to get access, say, to a data source, which usually you would do in a Java EE environment to get access to a container configured JDBC access layer or access driver. You use annotations like post-construct or pre-destroy just to get a notification that something is happening with the Java class if the web service is initialized or if the web service is dumped because the request has finished. Also in Java Server Faces, not available in 1.1, a managed bean, for instance, doesn't have any initialization. Yeah, it just has a no argument constructor. So you call the managed bean, or actually the system calls the managed bean and launches it without initialization processing. So you could have a property injected through the managed bean configuration, but that's not the same as initialization code. If you could use now annotations, you get a notification when a managed bean gets launched, when it gets started by the system, so you can respond to that. And also, you get notification when the managed bean is garbage collected, actually when it's gone out of duty. So you can do some kind of cleanup work or housekeeping. There are some specific Agb annotations like run as, roll aloud, which is something that you found before in XML metadata. So there were always some deployment descriptor with Agb that gave you the ability to configure container managed security in this case, to allow or not allow a user to execute a method or to access to data. So that's all now in a very simple annotation. We'll see how annotations look like. Let's have first a look at the progress that was made in Java EE 5 with Enterprise Java Beans. Now, I wasn't born with Java. I wasn't even born as a developer, nor am I a developer today. But who was born with Java? So who was born in 1990? Okay, maybe you would be too young. Now, what I want to say with that is, to some point, yeah, where I was developing with another tool, I had to go to Java. So I came from a 4GL background. Honestly, I knew how to push the mouse, and that was it, right? The rest was magic. The tool was doing it for me, and it was exposing all the buttons and all the widgets I needed to work with. So then my group actually got merged at Oracle with the Java group. And that was, for me, the initial flag they raised and said, well, buy yourself a book. So I went to a library and bought a book. And to that time, everybody was cheerful about Agb 2.0, Agb 2.1. That was it, right? So I went to the library and bought a book about that. So with my background, not a Java geek, so I looked into the book, and I saw for Hello World I needed six classes. One class I understood, this had these print out Hello World in it, and the other four were just, cryptic. I didn't understand them. Obviously, there were some tools that allowed me to generate those classes, but still I didn't understand them. So I felt that there was something wrong there. And it took the industry, I guess, 5 years to get the same opinion, to change it. As said, to that time, it was working good. It was really doing its job. And people built a proactive system with it. But from a productivity point of view, which I as a developer would be very interested in, to see my work being eased, be faster. Yeah? I'm not talking about runtime performance, I'm talking about development performance. And this is what Enterprise Java Beans 3.0, at least from my perspective, really does a great deal on. As I mentioned before, before the change in the standard happened, there were some implementations, namely Hibernate and Toplink, that Oracle acquired some time ago, that had a POJO persistent layer. So actually they did something that should have gone into the standard. And it took another 2 or 3 years, and then it went into the standard. So in this case, we see a very positive effect of an open source product or a vendor-specific product feeding back into the standard. So not everybody can use it. I think I lost my microphone. It will be more static now. I stopped moving. Yeah, I guess this is kind of the filter. If the one in the Technic, if he likes the presentation, then he keeps on going. Otherwise, he switches you off. I think I need to work on my presentation skills then. So, coming back to POJO. So we have POJO-driven persistent architecture that, coming from open source and coming from a vendor-specific implementation, now went into Agb. Initially, they started with Agb session facades and Agb entities before they pulled that out and made it JPA, which is a Java persistent architecture, so that you can also use it standalone. So you're no longer tied into a J2E container as it was with Agb 2.0 and 2.1, which is easy to test now because now you can have standalone testing facilities. So this is an example of an entity. So all that this example basically does is it references a table. So it's an object typically represents a row in a table. You see annotations always starting with the @ sign. It flags itself as an entity, as a metadata, so it's understood by the container and by the compiler. It says that it references a specific table. In this case, it's a customer. It flags one of its attributes as a primary key, as an ID, and also the column where it maps to. And the rest is just getter and setter. So that's your entities, so nothing else now. So all that you would get on top of that is just an interface, a normal POJO interface, what they call POJI, yeah, so a plain old Java interface, which is a business interface, which makes a lot of sense, especially if you coded Java in the past. So to insert data, you use a new facility, which is the Entity Manager. The Entity Manager is a resource that you get from the container. So again, using the Java EE standard helps you to leverage services that are provided by the containers. One is security, another one is resources, and another one is, in this case, the Entity Manager that allows you to perform tasks like persisting changes or merging two objects, so to have an update. In this case, the small little code that I have here, so I can also highlight it a bit. I just sat in the back and I saw it's very small if you're in the last row, though the last row typically is the most cozy row, so this is why many people sit there. You see I have a method, and in this method I create a new entity, and then I provide some attributes, and then I call the container for that. But to do that, I would have to first get access to that. And there you see is an annotation that at runtime will inject, again this word, inject, will inject the reference to that Entity Manager to my application. Now the benefit for my application in this case is independence, because I don't have to do any specific class lookups. So I would just say I need to have the Entity Manager referenced to me, and then the container takes care of that. So let's have a look at the development environment. So, of course, we're a database-driven company, so I'm not going to create the entities now from empty air, which you can also do. You can start with your object model, and especially if your background is object-oriented modeling or object-oriented programming, then you might prefer start with an object and later on see how you can squeeze your object model into a relational world. Now I prefer to do the opposite because, again, for my 4GL background, I typically start with a well-designed database and then see how I can create objects based on the database. And either way, what you decide, JDeveloper is quite helpful with that, not only in JDeveloper 11, but also in 10.1.3, where we also supported Agb 3.0. You can create entities from table. That would expect you to have an existing database. It mustn't be an Oracle database, it could be any database that you work with, so we were not really picky on that one. So I have the option still to build Enterprise Java Beans 2.0, 2.1 applications, Agb 3 entities, and all that I would need is just follow the wizard. Here I do have the choice to say I want to work offline, so I do have my database definitions offline within a specific workspace, so I don't need to be connected, or just online, which in my case will do. I create a connection. This is basically a tool connection, so that connection is within JDeveloper, and it will be written into a data source. So when you deploy your application, JDeveloper takes the definition of that connection and puts it into the data source, and it configures the whole thing to use the data source. One of the benefits you gain out of this is that you could specify a connection beforehand on the IDE. So instead of what I'm doing here, providing my database connect while building it, you could just create it first, and then whenever you build an application, there's a magnifying glass. You just look up the connection, so you don't have to remember the connection all the time. So once you configure it, you can reuse it, or as in my case, for demos, it's also good to show how to build the connection. So I build the connection, test it, database is up. So next step is, now it connects to the database, and then I will be introduced to a panel that allows me to query the database for the tables. And then I can decide, okay, I want to build my application based on departments and employees. And now what happens is, I'm just stepping through it, what happens is it creates me the entities. So the class, the customer class we saw before, now is for my departments and employees. If I double click on that and open my departments, oops, that was the database representation. I want to go to the entities. Here's my department's entity. Then you see what we do is we just added some named queries, which is the obvious one, is the go for everything query, yeah, because that is the most common query that you have in your application, one that just shows you a list of everything. Plus, we put all the annotations in place. You can change your annotation. We also provide you annotation inside. So if I press Control and Ta-da! I'm allowed to dance again. Okay, so we provide annotation insights so you don't have to really learn annotations by heart, though it's always good to know what you do. So what I did in preparation for this presentation, because the query is not only that you can query for all, you can also query for a specific object. Now, the query, funny enough, is in the entity through annotations. So there's no external file that contains the query. So let's get rid of my named queries, because, as I said in preparation, so I created a code template that actually puts in the queries that I want to work with. So I could use reformatting. No, it doesn't do it for annotations. Anyway, imagine that would be beautified. So, and you would be surprised I did the same for employees. So code templates is something you put in the preferences of JDeveloper. Some already exist. You know, the most common ones like for loops or try-catch blocks, that's all prepared for you. So let's compile it. Good, the class compiles. So the next step now would be for me to create the access layer, because you're not working with an entity directly. So you use an access layer, that is the session facade. And again, I go create a session bean here. And when I step through, you see that all the queries that are added to the entities plus the functionality provided by the container is displayed here. So now you can further restrict what are the methods you want to expose to the session facade, which then is used by the application developer to build the application, the front-end application. So let's stick with everything. So once you're done with that, one of the emergent needs that you had in the past was testing. You always have that. So you may use JUnit, but even in the past with JUnit, if you used Enterprise Java Beans, you always had to have a container involved. So there was no testing outside of the container. Now in this case, because the container exists, I can now create a standalone version of it. So despite the fact that I do have an application that could run in a J2E container, I could run a test client to test it standalone. So in this case, what I could do, I think I have to go to let's see if it's exposed here. Well, edit session facade is just something you can go back to. I'm just trying. That's a new sample client. Well, one of the options is to create a new sample client, which is just a Java class with a main method in it. And then from JDeveloper, run your Agb, which then would spawn the container, execute the Agb in there, and the Java sample client will call it. But you can also build I just need to find it. Persistence, right mouse click, and there you can build a new, what we call new Java service facade. Now this steps you through. You say, I need to create a new persistent unit, and here I can specify if I want this persistent unit to be standalone. And as soon as I have that, I could use it outside of the container, can test it there, can create my JUnit tests without the container. Plus, I could of course use a standalone in my standalone applications. So let's leave it there for the moment. So I will come back to the similar model in a second. So let's talk about dependency injection. So that was, or that is, still is, valid code for Java EE 1.4 for you to look up to a resource. In this case, it's looking up a remote object, trying to get access to an object called card home. And this is what you actually needed to do to work with a specific entity. So you see a couple of lines of code that are not too damn difficult, but at least they're kind of unnecessary, because now with the new dependency injection, what they do, instead of using a JNDI lookup that you manually perform to get access to a data source or to get access to any kind of resource that you want to work with, you can have this getting injected at runtime through the container. And this is what you use annotations for. We just saw one example where I can get access to the entity manager through an annotation. So as a developer, I would just grant that this resource is available to me. So I put an annotation there, assign it to a variable, and I can keep on going in my class. And then when the application gets deployed to another application server, I don't have to think about it. You know, in the past, especially if you develop Agb, you know that there were deployment descriptors that you had to implement. Now, the deployment descriptor were different for each target platform. So if you deployed to Oracle, there was a different deployment descriptor, though they were all doing the same thing. It was just the metadata was different. You couldn't take an Oracle deployed application, carry it onto JBoss, and just run it without change. You had to create specific deployment descriptors for JBoss. Same when you went to IBM WebSphere or to WebLogic. So that was all difficult, because you as a developer, as a deployer, if you really have this separation of duty, you as a deployer, you would have to know exactly what is the target platform, create the deployment profiles for that, and that was additional work unnecessary. Now within dependency injection, you as a developer, you just say, inject this resource to me, and I don't care how you do that. So dependency injection, the container takes care of all the initialization, so the resource is just there, and you can use that for resource injection. I mentioned that. A session bean reference, so if from your client you want to reference a session bean. Entity manager, we saw that. Web services, we will see that at the end of the presentation, and that's all based on a common set of annotations that got into Java EE5. So let's have a look at dependency injection and what I can do with that. So again, I created a similar project to what I showed you, where I had Agb session facades accessing to entities. And then what I wanted is, though I'm talking about Java Server Faces in a minute, I wanted to build a web UI with Java Server Faces. And following my paradigm of no strings attached, I didn't want to use any framework right now, like ADF. So we will see ADF and the benefit it brings in a second, but I wanted to build something without ADF at all. That means that I need to have a model that allows me to populate my table with information I get from my entity Java beans. And this model, in the most common case, is the managed bean. So I do have a managed bean to create the table model, but for the managed bean to get data, it needs to have access, basically, to the session facade. And in this line, I use, as you see, an annotation to point it to a specific interface. And then the container will help me to look up that resource. So the container will look up that resource, will find it, will pass me the handle, and from then on, I can use my local interface, which is the name of the variable, which accesses my Agb session facade local. I can use that variable to create my table model. So, and all that I need to do now is just need to go here and run it. And that will then give me a table of employee IDs. So you see, instead of me doing the lookup, configuring the web XML file with the session facade so that it knows what to look up, then me doing a lookup to that named reference in the web XML file, all I have to do is just put in one line of code. And that's also something that the IDE can help you with. So you don't have to know all that. You just say, okay, I need to have a handle to the resource, and then the IDE is taking care of that. If it's a good IDE, like JDeveloper. There are always only good IDEs out there, I guess. They all have their strengths. So it takes a bit to start up the container. So now it's coming up. Okay, and then you see my table populated with the data that comes from an Enterprise Java bean. And you see the lines of code I have within my application is just one line to get to the source and 4 lines to create the table model. Similar, I could then use the reference to my session facade now to perform insert, update, and deletes. All I would need is take my variable, get the object that was updated or created, and squeeze it into the persist method. So Java Server Faces. I will have a bit longer talk this afternoon about Java Server Faces when we talk about possible improvement areas. But most important to mention for Java Server Faces is the evolution that web development has taken, starting from a static HTML file approach up to servlets, then the first templating approach with Java Server Pages, still markup driven, and now with Java Server Faces we have a pure component model as I know it from 4GL and where I feel comfortable. But on the same time, not looking at the technology, we see how we can improve productivity by that. Because now everybody could create me a component, and I could take the component either through open source or a vendor-specific component set, put it into my application, drag and drop it in, and I get the functionality it provides. So the table that you saw here is a component. Now with all its scroll bars, it's a component. So I don't have to code for that. So I don't have to deal with the JavaScript for that. Now, if I need a different component, I find it, for instance, in Apache Tomahawk, I would just take the Tomahawk libraries and drag and drop the components in. So that's a lot easier for the developer to find the right component, and still you have the chance, if you don't find the component you're looking for, to build it yourself. And then the tool will understand what you built, because you use some kind of clearly defined APIs. So the architecture of Java Server Faces sees that there's a UI component. Well, that is the button, a text field, a table. It does know nothing about its rendering. It doesn't know if it's rendering on the browser, on an iPhone, or on a telnet server. All it does know is if it's a button, you click on it, there's an action it has to call. You'll be able to specify width, a height, but you don't know if the target browser or the target device supports width and height, or if there's some kind of defaulting. But you don't care as a developer. All you care as a developer is that your application works. Then we have the managed bean, which is the model that accesses, in my case, the Agb layer. And between the UI component and the model, you have expression language. This is what I referred to in the beginning. It's a dot notation, it's a scripting notation, as you know it from JavaScript, that allows you to tell the value property of a text field which method it has to call in case of read and update. So there are some changes when we go from Java Server Faces 1.1 to 1.2. One is the common expression language being used. Then some performance improvement, like how the tree is rendered. Java Server Faces always keeps a kind of a tree in memory on the server side, so the server knows about the state of the client, of the browser client. So the next time you come back to it, you don't necessarily have to pass in all the information back because it knows about the state. This state, however, needs to be saved somewhere to be recovered. So it has to bring something, either keep something on the server and memorize it, or bring the state to the client in form of a token. And then when it comes back, the next request to the server, it looks if there's a tree that exists, because everything is an object that it keeps. So it would take slightly longer if it has to create the object. So it looks for if it can find the objects, if you have visited the page before. And this is what it does through the state management. So now let's have a look at how, with ADF, which is the binding layer that Oracle proposed as GSR 227 for the standardization, how that could do an even better job. So what we saw is that within my J2E layer, I had a managed bean, and then the managed bean was using annotation to access to the resource. Now that is fine, but still I had to create a table model. So I would have to understand what a JSF component requires as a model, or if you use struts, now what is the model that an iterator expects to create you a table. So this can be simplified in that we put a binding layer between the user interface and the business service side. Now you can see it as two different worlds now, because if you're on the upper world, if you're an uptown, so to say, yeah, if you're building the application, you don't really care if you're talking to a web service, to an enterprise Java bean, or if you're talking to Beeple, or if you're talking to a Pojo, because this abstraction layer always shows you the same set of APIs. So you call the abstraction layer and say, execute that query, and you don't care where the query is coming from. On the other side, the business service developer doesn't need to care what UI interface you're building with. What are the limitations of the UI interface? So all that you need is to some point agree on the methods that you need, on the exposed business functionality. As soon as he does that, you can create a data control out of that. And this is where I come back to my application I built a second ago. So let's close all the windows. So I do have my session facade exposing all the methods. All I need to do is right mouse click, create data control. Choose which interface I want to have, and internally we do the lookup and we generate a couple of metadata out of that. So the metadata is first of all for the product to understand what are the exposed methods, so they make them available for drag and drop. Second, you can also use the components to provide additional information. Let's see, that goes here. Go to properties. You see they all have some kind of properties. Even if you forget to specify on an entity a primary key, you can set it in metadata. There's something else I want to look for. So here you see you can specify in the metadata if content should be updatable or if it's unique, if it's queryable. So you can override basically what the definition is in the entity through the metadata. And the one I'm really looking for is a very unique feature that you get out of that. Names, method names, and attribute names are not really useful for the end user. So you might have a dept ID or a managed ID, which it doesn't say anything to the user. So you want to map that. So what you typically do is in your end user interface, in the application you build, you override the prompt. So if there's a dept ID, you call it department ID, and then you want to have it translated, just in case that you have a global application that runs in different countries as well. Now you do this for every page, which means that if you forget to do it on a page, it shows us a dept ID, which is not what you want. Now you can use that metadata to specify UI hints, which is then automatically picked up. So I can override on the entity level in the metadata and can say, whenever there's a dept ID, that should be dept department ID. And then without me caring for how that works, as soon as I work with a product, I just drag and drop a table in, and all the table headers will have department ID instead of dept ID. And then if I need to change it, I just need to change it in the metadata and it will be picked up at the runtime. So there's some kind of additional functionality that we can provide. Now what I wanted to show you is, similar to the table I built before, how do you build the table now? So let's put the ADF Faces library in there. It's in there already, okay. So I have a Java server face page that I built. So I start with the Faces configuration file, which you also use, similar like in struts, to perform or to specify the browse department that you use to specify the navigation from one page to the other, just declaratively, as you know it from struts. So I came up with an empty page, and now what I want to do is I want to create a table. I didn't show you how I create the table with the resource injection. In fact, how I did it is I dragged and dropped a table from a component palette. It comes out with a dialog, and in that dialog I had to tell it which method to access and then with which attribute from the method to take. So I had to type it in, which is a more manual approach. Now with ADF, all I would have to do is I would go to my data control that I created, and this is exposing all the method that my Enterprise Java Bean is exposing to me. And here I have, for instance, departments find all. And all I need to do is just drag this over and say, you're going to be a table. And I could say, well, have row selection, which makes a lot of sense if I want to sort my, want to select a row, then navigate to another page to edit the department. The benefit you get out of this is you're no longer implementing the model. The model is implemented for you. So we hook up to the method. If you have dropped, for instance, something that is get object by ID, we would render this as a parameter form. So you can just start on typing in and testing it. Using ADF for your development, now I would say we don't have official testing, but I would say just from my experience and my subjective feeling, boosts up performance in development 10 times. Because once you have the model, you just work drag and drop most of the time. You build most of your application just with a drag and drop gesture. And for the remaining, as usual, the remaining 20%, this is where I really code. But this remaining 20% really make the difference between your application and someone else's application. But the benefit we take out of this is we use two standards, Java Server Faces and Enterprise Java Bean 3.0. And we bring them together in that we put a smart layer between. And the smart layer, the only responsibility is that no matter what you define here, for instance, you will have a specific interface name. From this point, from the application developer point, you don't care. You want to work with a consistent set of APIs. And same table as I showed before, I now have here, I can scroll. The change is just then that I dragged and dropped the table on and everything was magically done for me. Magically in the sense that I can work with it, so it's not hidden from me. But while showing a browse table is an easy thing to do, now think, what if I needed to have insert, update, and delete? Now I want to select a table from here, and then I want to create a button, and then when I create a button, it should go to the next page, and on the next page it shows me a form. I'd update the form, it comes back to and should show me the updated values. Now that's easier to get with a metadata layer if I can work with drag and drop, because as you see, the table keeps track of the selected record. Now all I need to do is, I need to go, for instance, to a next page and say, find this selected row, this object, by the object reference, or by the ID. And then it shows me exactly that row. I update it, and then I come back. And that's a lot easier if you use a metadata layer. Plus, always keep in mind, you may have new hires in your team. People that come to your team that you need to get really quickly up to speed. Now, instead of teaching them how to code against POJOs, code against Agb, code against web services or BPOL, you just teach them how to code against the binding layer. So that's the benefit we get. And this is also something that we are not only showing at conferences, we're using it internally. So whole Oracle applications is built with ADF as a binding layer. Not because they can't do other technologies, it's just because it's more proactive to them. So let's talk about web services. There's an important change between web services in Java 1.4 and web services in Java 1.5, which is more in the implementation detail. It's using JAX-B instead of RPC to access, instead of remote procedure calls to access a web service. Plus, it's using annotations. It allows you to use web service metadata. One metadata I didn't show you for Enterprise Java Beans is there's an add web service and an add web method annotation. If you have a session facade, when you don't want to build a web application, but you want to have a web service out of that, all you need to do is put add web service on top of the session facade. When you deploy the Agb to a container, it turns into a web service. So you can right away work with that as a web service then, which is a huge improvement. So, the important fact here, just to stay in time, and because I have a demo to show, so we'll just mention the two annotations that I use, web service to flag a session facade or to flag POJO as a web service. Plus, if I don't want to expose all the methods as web services, I use add web method. If I use add web method on a specific method, then only this method is exposed. Post-contract pre-destroy, I just mentioned that. It's for you to do your kind of housekeeping. If you need to do some kind of initialization code, if you do some kind of logging or whatever resource you need to get on initialization of a web service request, then you use a post-construct. Otherwise, you use pre-destroy, which is before it gets garbage collected, you want to leave some resources or whatever you have to do. So, annotations. You see, here's the add web service example and the add web method. So I have a string, say hello, that I expose as a web service. When you deploy it, when you run it, then this actually gets turned into the web service. So no longer need to have an external WSDL file. You don't have to create one, so that all can be annotated. It doesn't mean that WSDL files stop working. So you can still have a WSDL file and edit it, and can also go this kind of top-down approach where you first create the WSDL file and then from the WSDL file create the web service. This is still an option. But just for purists, if you're starting from a POJO approach and this is all what that is about, then you can use annotations instead. So let's go to my example. That's just the overview, but this will mostly cover in my demo what JDeveloper 11 supports. One thing that's not in TP4 that will be in the production version, and I didn't cover that for the web service, is asynchronous web services, which is a huge gain in Java EE5 because in the past, when you had a web service, they had a long-running process. So you called off to a web service, and if that web service wasn't Beeple that you can left alone, then you called the web service, and the web service kept on busy, and there was no way for you to cancel it because it was synchronous calling. So either the connection timed out, or you had to wait. Now with asynchronous web services, you can say, okay, I know that there is a specific web service that takes so long, so you just do it asynchronously, and if you lose patience, then you can cancel it. So that's also new in Java EE5. So then we do have a new web service tester within JDeveloper 11. That means that you run the web service within JDeveloper. You don't have to deploy it. So you can create the web service, and then you run it within JDeveloper. It comes with a tester. It shows you the communication going between the virtual client and the virtual server. It allows you to test parameters to query, for instance, for a specific object. And this is what I'm supposed to show now. So what I did is, first of all, close that. We don't need it here. So what I have here, I have two POJOs. So I have a customer object, which is just a normal POJO. And then I do have my web service POJO, which is just an array with some data. So that's fully hard-coded. So I could access, of course, the database, but I made it simple in this case. So I have a POJO that I could run from a Java class if I wanted, just print out the names. Now I want to turn that into a web service. As easy as it is, I could say create web service. Now it steps me through the process. And at the end of the process, what I will see in my class are annotations. Annotations that flag that service as a web service, or the POJO as a web service. You see I have a get customers method. I keep that in. I can decide if that should be a stateful service or a non-stateful service. And everything I configure in here, so everything I would set within that wizard will end up as an annotation within the class. So nothing would be generated as a separate class, or not much at least. So just stepping through it, let me put my customer class in there. And hit finish. So this is now starting to create the web service. Here you see this icon slightly has changed to indicate that this is a web service. Opening it, you see here is a web method edit. There's a web service edit. It gives me the name of the service, and it also the target namespace and the port, the endpoint that I use later on. So now within JDeveloper, I can already test this web service. I go to the test web service option. I have the HT analyzer open, so we can use that as well. So that would show me the traffic between the virtual client of the tester and my web service. So one thing you see here is that I have a small little control panel that would allow me, for instance, to specify parameters. So if my web server requires input parameters, it will show me a form for me to type in the values. So mine doesn't have anything like that. So just call the service, and here you see the response. So I can see my service working. If there was security involved, if I had a username and password to provide, I could do that here as well. So without leaving JDeveloper, without deploying it, I can test it on board. And the Agb Analyzer itself would also give me some information about the traffic. So there's not so much traffic now, but at least I get an idea of what's happening between my web service client and my web service as it is deployed. So that's one thing I can do with that. The next thing, of course, is if I want to build something with it. So to have a web service is nice, but to have an application using a web service, that is SOA. Well, considered to be SOA. There's much more in SOA than a web service. But my favorite starter typically is when I start talking about SOA. It's like when you attend a SOA session. Yeah. So nothing against SOA. SOA is great. When you attend a SOA session, the first thing people say that is, SOA is not all about web services. There's much more in SOA. And then they say, now let me show you what I have in store for web services. In fact, there is a lot more about SOA, but people love to talk about web services, even I. So actually, I have a slide like that. So what I want to do now is I want to show you how to build an application against such a web service. Now, I would just run it just for the sake of it deploying to the container, so I get my WSDL reference. And then I have two options to build an application. One is to create a web service proxy based on that WSDL file. Another more elegant way is to build a web service data control, so I can use my binding. You know, as I mentioned, as a developer, I don't really care if I'm talking to people, web service, Agb, Pojo. I just care for the methods I have to call to get a specific application task going. So here I do get my, here's my WSDL file reference. So all I do is, instead of closing that, I could have a separate project for my data control. In this case, I just use the same project. I go to Web Services in my business service tier. And then there's an entry for Web Service Data Control. It needs a name. And then a reference to my WSDL file. Change that to localhost. So I step through it. It accesses a web service. It shows all the method exposed, so I can pre-select which one I want to expose to my application developer. Could specify user and password if there is some security involved, and finish it off. Again, I have the same set of metadata, and always keep in mind the same metadata allows me now to specify additional validation like range validation, regex validation, plus I can specify what the names, the prompt labels are. So going now to data control, I have a new data control here. Let me first create a page. So let's get my ADF Faces libraries in there because they're ADF Faces components, because they're much nicer to use. Okay, so what I do is I just drop the return value as a table. I could also have a row selection. Based on the row selection, I get the value that web service provides me. I can then have a follow-up call to a method that takes the web service response as an input argument, and let's run it. So now what happens is basically I have a web service. This web service is not directly accessed by the developer, by me, but I abstracted it with a binding layer between, and then the rest of it is just declarative for as long as I want. Of course, I can use Java code within MHB to access this operation, to execute the web service. But then I would work with an API that never changes. That's an API that I get from the abstraction layer. I'm not saying you have to use ADF for that. I have many customers that prefer to really stick with the no strings attached slogan, and they actually prefer to do everything manually, to stay in control, as they said. You see I have 3 lines here showing the data that I have. I could juggle this a bit around, so swapping the columns. So basically, you can do whatever you want, but there's always a way to improve your productivity. There's always something that you can do to boost developer performance. Not only runtime performance, but developer performance. And I think that's pretty much what I had to say about simplifying Java EE development. So standards are important. Open source is great. J2EE 5 has improved a lot, and we will see more improvements as we go with the Java EE standard. Whatever you want to do, you find a solution within JDeveloper. If you want to go with one of the Oracle frameworks, fine. But if you don't want, then you don't necessarily have to go for another IDE. You can have a team of developers working with their favorite technology, just using JDeveloper. And that's it. So thank you very much for attending. And if there are questions, I think I have 2.5 minutes left. Okay, no questions? Thank you. Or there's a question. You always have to say thank you, then they come with a question.
Check. Is there any way to automate the testing which is specified in that slide?
automation of which testing?
The web services testing.
The web service testing, well, you could always try to build yourself, well, there's no web service testing that allows you to run it standalone. What we could do is you could write a proxy class that then you use with JUnit to test. But you always need to have the web service deployed.
Okay.
Okay? Thank you again, and bye-bye.